Hi, my name is Amin Maramai, and welcome to my paper's audio slide presentation. In this paper, I have the overview on one of the cloud computing environment problems, that is virtual machine placement. What is virtual machine? A copy of the memory and stored content from a particular machine, including the operating system and everything else that is needed to run an application, such as software and data, called the virtual machine. And the way in which virtual machines are mapped to physical machines, called the VM placement. For the suitable mapping of virtual machines to physical machines, we need to know the capacity of physical machines, virtual machines' resource requirements, and lots of factors. In general, VM placement method can be divided into two categories. In one category, priorities are electrical energy consumption, and that is because of increased demand for electrical energy consumed by resources, and also the cost of it. And in another category, priorities are applications quality of service. These approaches try to increase the standards of received services. VM placement problem can be formulated as sum of problems. The first type as a constrained programming. This is a two-stage method, local decision and global decision. Local decision is related to every application's environment and use the function that maps a resource capacity to a utility value, and the results of this function communicate to the global decision module in each iteration. Global decision takes the local decision as input from all applications, so tries to maximize the global utility function. This module involves two phases, provisioning and placement. Provisioning phase aims to find the virtual machine allocation list for each application environment and simultaneously tries to maximize the global utility value. And placement phase takes the allocation list as input from the provisioning phase. And global decision method creates a single list from all lists. This list contains all the virtual machines running in the current time, and the aim of this phase is to minimize the active number of physical machines. The second type of formulation is stochastic integer programming. This is beneficial in cases where actual demands don't seem to be framed. However, the distribution of demands is understood or is calculable. The demands and costs aren't fixed. However, we can estimate them to support the distribution curve. Thus, this formulation type would be helpful. The third type of formulation is bin packing approach. This can be used to realize the particular mapping of virtual machines to physical machines. And physical machines can be thought about as bins, and the virtual machines can be thought about as objects to be placed within the bins. And the aim is minimizing the quantity of hosts needed for virtual machines. The fourth type is genetic algorithm. This is a heuristic based on search technique, and notably helpful in issues where objective functions dynamically vary. Genetic algorithm typically starts with a population of solutions and applies genetic operators on them, and finally ends up providing best solution. We have some of algorithms have been used in open source systems. For example, ranking algorithm in OpenNebula that takes requirements and predefined rank as its input and produces the resource number in which to place the virtual machine as output. Or greedy first fit algorithm in eucalyptus and nimbus, that whichever node can run virtual machine found first is selected as the host for virtual machine placement. Eucalyptus and Nimbus also use round-robin algorithm that records the last position visited and start from the last visited position next time. Thanks for your attention.